Oh, hi, microphone that wasn't working. Hi, Ryan. Hi, Thomas, if you're still watching. Well, that's helpful. Said nobody ever. Okay, so these little notations. He turns in something, because I grade something. Okay, let's come back. Shh. What's the little plus? What am I talking about? Ooh, except I did them switched. Luciento, what's supposed to be in the top one? Yeah. I'm talking about the little baby exponent, right? Although it's not an exponent, it's a notation. And the notation of a minus or a plus in the exponent spot of a number is meaning from a little bit below or from the left. But I like the idea of a little below, approaching from a little below C. And then if there's a positive, I'm coming from, as x approaches C, positive, yeah, coming from the right. A little above, good. And I think the above and below was mostly how we were referring to the red car, the blue car, the red guy, the blue guy, coming from a little bit below, a little bit above. Remember, there could be all sorts of craziness going on, but zoom in, like the table, zoom in on whatever x is approaching, whether you call it A, whether you call it C, just some sort of constant, a little bit below, a little bit above. And I even use this notation of like the L1, L2. What's the guy from below approaching? What height? What y value? What's the guy from above approaching? What height? What L? What y value? And the limit will only exist if L1 equals L2. And if L1 does not equal L2, what do I say about the limit? The limit does not exist. I'm not caring about at, I'm caring about the approach. And the limit will only exist if the one-sided limits agree. But we can still say answers for the one-sided limits, and that's what the example down below is for. P.S. Happy Tuesday. Happy you're not taking an AP Spanish exam right now. Ryan's not in AP Spanish. Thomas? Is he? Okay. Here, should I just give you this microphone? You just don't do it. Okay. Well, you're already doing it just from afar. Now I want you guys to ponder. This is where number 37 got hard. I want you to ponder, not with a graphing calculator. How could you figure out at least something to do with that graph? And if you think nothing, in Algebra 1, when you knew nothing about graphs, you made tables. If worst comes to worst, make a table and plug in points. -2, -1, 0, 1, 2. If worst comes to worst, make a table. Nobody is completely bereft of any options of graphing. Everybody can make a table. Be bold, be proud that you are at least trying something. Who's making a table as we speak? Who's already made a table? Who's graphed it some other way? Okay, so everyone should be making a table. My two people that actually are, I'm very proud of you. If you're still taking notes, okay, good job. My question is, would you have kept going and actually tried to graph like I asked? Don't use your calculator. Try to do it by hand. Face the uncomfortableness. That's how we grow. Ooh, lesson. Andrew. No.
Is it because it's inside the absolute?
Yes. You can pull out the 2. Totally valid. Because a positive 2 inside or outside the absolute value has no effect on. We can pull out the 2, but the x, positives stay positives, negatives change. I can't pull it out.
So you were would it be 2 an absolute value of x over?
You can pull out the 2, but not the x. There is a way to rewrite this using a piecewise definition of an absolute value where maybe some things could factor. Now, I'm going to go ahead and take a quick second to actually steal this. Give me a little bit, well, E for effort. To try to steal this, there we go. Give me a little bit more room on the next page, okay? We should have the one-sided limit stuff at least. Now, I was saying if worst comes to worst, you can make a table, and I am totally standing behind that comment, that statement. If worst comes to worst, you can always make a table. So I'm going to do a little table with an x and an f of x. We did it with polar when things got weird. We did it with parametric when things got weird. Fine, do it with algebraic things when things get weird. If I do -2, -1, 0, 1, 2. Because most of you don't want to plug in fractions. Lazy bums, but that's okay. If I plug in -2, I would have a -4 in an absolute value all over -2. Isn't that going to be 2? Positive or negative? Ooh. If I plug in a -1, that would be a -2 all over -1. Isn't that going to be a -1? Nope. What's it going to be? A -2. If I plug in 0, I don't really know. It's 0 over 0. That's weird. Doesn't exist. If I plug in 1, I have the absolute value of 2 over 1. Isn't that going to be 2? If I plug in 2, that's going to be absolute value of positive 4 over 2. Isn't that going to be 2? That's weird. There are lots of 2's. Hey, isn't that what we would kind of think if we did some really illegal math and we did this sort of thing? Now, super illegal math, because the problem is if we did that, wouldn't the answer always be positive 2?
Yes.
But what did we notice over there in the table? There's -2's and positive 2's. Now, maybe we just didn't branch out enough. Let's go ahead and plug in, I don't know, -10. -20 over -10. Sorry, absolute value of -20 over -10. Wouldn't that also be -2? Is everything -2 below 0? Wait, okay, hold on. How about above? Let's plug in 176 times 2. It's going to be a positive 2 times 176 over 176. The 176 is canceled. You get a positive 2. Is everything going to be positive 2 to the right? Yes. Why? Because the absolute value of 2x all over x is equal to the piecewise function of sometimes, the 2 doesn't really matter, sometimes the x is going to flip signs if the x is a negative number, and sometimes the x is going to maintain the same sign if x is a positive number. And if you notice, what happens if I have x over x? Isn't that just going to be 2? What happens if I have negative x over x? Isn't that going to be -2? So my function is going to always equal -2 for any negative x being plugged in, and my function is going to always equal positive 2 for any positive value of x being plugged in. What does that mean? Well, what that means is, if y is a constant, doesn't that mean I have a horizontal line? What would happen if you graphed? It would look a little broken. Your table tells you that, and you didn't even have to think about the piecewise definition of an absolute value function. Your table tells you that. Don't be afraid to sometimes go back to the basics. Don't always have to think of the elegant solution. But the piecewise definition also very clearly shows the -2 and 2. And why is that so important? Well, kiddos, what's the limit as x comes towards 0 from below? Even if I use -0.01, -0.001, -0.0001, we just talked about all of them are going to equal from below -2. All of these, -2, -2, -2, -2, -2, 2, 2, 2, 2, 2, 2, 2, with negative, 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 negative. What's happening as I come from above? Positive 2. If I compare the two limits, the two one-sided limits, what do I have to say? The limit does not exist because the one-sided limits do not match. Equal. Agree is the word that I like. If the one-sided limits do not agree, the limit does not exist. If the limit does not exist, well, sometimes the one-sided limits do not agree. We've seen a few different cases. If the one-sided limits do agree, what do we say about the limit? Louder. If the one-sided limits do agree, the limit does exist. If the one-sided limits do not agree, the limit does not exist. So fill in the blank. If the one-sided limits agree, the limit exists. If the one-sided limits do not, then the limit does not exist. Does that make sense? Okay. So, Dean, let's take this to number 37. Sound good? So in Dean's number 37, I think it was back here on the page before. Let me get my snipping tool all ready to go. Hopefully it's opening. Number 37 said, ooh, hoo, hoo, take this guy. Well, what happens when you plug in, we failed just a little bit. Well, we followed the directions, because the directions technically said, oh, it didn't technically say. What should we have technically done first? When talking about going to 0, yeah, we should have seen it was a 0 to 0, keep going. Sorry, the limit wasn't written, so I didn't do a good job of plugging in. But 0 over 0, keep going. What happens when you look at number 37 over here? Plug in 2. 0 over 0, keep going. But how? It's an absolute value. Well, you tell me, which one makes more sense? The piecewise definition of an absolute value or plugging in a table? Sure. So let's plug in a table all around 2. Ready? We have our x, we have our f of x. Let's figure out what's going on. P.S. On the AP Calculus exams, we have this sheet that's called When You See, You Think. There's when you see and all these comments, all these statements, all these problem-solving wordings that can show up on an exam. You on break? Go team. Hi, an AP Spanish student. On the other side, it's you think. Okay, so if you see this in a question, you should think of doing this. You should think of this graph. You should think of trying this procedure. You should think of this forever card theorem. Okay. I try to tell them some different things the AP likes to trick them on, and one of them is with limits, absolute values. So this isn't an easy concept, but it's not bad. We can always plug in a table and say, hey, what's going to happen as we come from below, I don't know, like 0 and 1, as we come from below 2, and what's going to happen as we come from above 2? Well, guys, what happens at 2? We already know 0 over 0, keep going. What if you plug in 1? Wouldn't that be absolute value of negative 1 all over negative 1? What's that end up being? Negative 1. Remember, absolute value makes it positive, positive, negative, negative. If I plug in 0, I'm going to have absolute value of negative 2 all over negative 2. What's that going to be? Guess what's going to happen for any value below 2? Negative 1, negative 1, negative 1, negative 1, negative 1. What's going to happen above? 3 minus 2 is a positive 1 over a positive 1. 4 minus 2 is going to be positive 2 in an absolute value over positive 2. I'm going to have positive ones. Are they agreeing? No. So what's going on with the limit? It does not exist. And why? Well, the piecewise function absolute value will stay the same only if the expression stays positive, which will only happen if x is greater than 2. But the absolute value has to flip, be the opposite if x is less than 2, because a negative flips to be positive. A negative flips to be positive. All these need to flip, and in math, to flip it, you multiply by a negative. All these stay the same, so I chill it and keep it the same. And as you guys notice, those reduce, and I end up with a negative 1 and a 1. So whether you think the piecewise definition or whether you think a table, either way you should be able to say, those do not fill in the blank. These two one-sided limits do not agree. So the limit does not have fun in there. Okay, so D, N, E. Does that make sense? Technically, it also says to graph. Oh, we didn't graph. Fail bot. Well, hold on. Can't we just do, and can't we just do, hey, we graphed. Dun, 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 dun. Absolute values, there are very frequently jumps because an absolute value behaves very differently before the separator and after the separator. Cool? Beans. All right, let's come back to notes, because there was a whole nother section of homework that you were like, ooh, oh, question. Yes, you may. So then looking at the problems, we got a little stuck with the difference quotient. Now, kiddos, calculus kids get stuck on this too, for whatever reason. It's really just substitution, simplification, taking a limit. Substitute, simplify, and we're good to go. Don't make it harder than it has to be. Don't make it harder than it has to be. But I'm going to try and help out just a little bit. I'm going to do some color coding, making things look snazzy and spiffy and all that jazz. Because for some reason, as soon as you see this x plus h, people start to freak out. Now, the nice thing is, on the AP exam, there really is no place where you actually have to solve this the long way by hand. But like doing 1.9, 1.99, 1.9999999 on your graphing calculator, like using your calculator was not the point of that. Getting the idea across of what it means to approach was the point. Same thing here with the difference quotient. The point isn't that ultimately you become a master at plugging into this definition. Ooh. This limit definition of a derivative that was the answer to the tangent line problem. Ooh, this is an important formula. The point isn't that you master it. The point is just that you understand how it works. So let's do some color coding. Let's see. Let's do pink. All right, maybe for the next one. Nope, it's purple. But maybe it looks pink up there because the projection sometimes makes it look different. Kiddos, what do we do when we have an of inside function notation? What do we do when we have an of inside function notation? What is this referring to? Whether it's f of 1, f of x plus h, f of 3, f of g. What do we do with the of? What is it talking about? What is it referring to? No, the of isn't referring to the function. What's the of referring to? What do we always do with stuff in parentheses? Independent, sure. Independent variable, or the substitute for the independent variable. So f of x, f of a quantity, is that quantity squared minus 1. F of input is input squared minus 1. Did I show you guys f of cal this year yet? Didn't I show that last semester? Didn't that show you f of cal? Oh, that's so sad. Maybe it's because you're honors. Function notation. F of whoever you want to give me, according to this formula, should be whoever you want to give me squared minus 1. So if I was teaching Algebra 1 and I pulled up my Algebra 1 notes on this lesson, there would be a cute little cartoon figure of a cow face. And I'd be like, sure, put a little cow face in there, and yeah, this isn't going to work out well, but that's all right. We'll just go ahead and give him little eyes, and then we'll give him like, I can't even do it now. Let's see a pig. Anyway, so the cow, wherever he is. Little circle, little circle. Okay, f of pig. Okay? Whoever's inside, who's going to be squared minus 1? The pig. It wasn't x, then it's a pig. If I were to put in f of, and put in like a 1,576, who's going to get squared in minus 1? Yeah! So whoever I have, I don't think I can do it again. That's why I'm not doing it, but I probably should. Little circle, then W, W, E. Oh, I didn't do the E. Anyway, so, right? Or the 1,576. So what if I do f of x plus h? Who gets squared minus 1?
Everything.
Yeah! Whoever it is. Whether it's a pig, whether it's 1,576, whether it's x, or whether it's x plus h, that guy gets squared. And why am I saying that? Stop. I don't know. Something. Just bring your foot up and be normal. Okay, so. Be perpendicular. That's funny. Anyway, so. How do I plug into this formula? You guys are honors. Can we do it all at once and not piece by piece? First of all, I need this guy. Second of all, I need that guy. Third of all, I need that guy. And that's just to plug into the formula. Who's the easiest guy to plug in? H, because it's just H. Sweet. Who's the second easiest guy to plug in? F of x, because he's right there. Put him in parentheses. Don't you dare write him without his parentheses. Keep them all together. Don't separate the poor little family illegally. Okay, put that binomial in. Who's the hard guy? That guy. But it's okay. We just talked about him, and you just saw me write him. It was an f of x plus h. Same family, but something new is being plugged in. Gotta think about it. I'll put little brackets so you can see the families. Here's a binomial. Here's a binomial. Here's your f of x plus h. Here's your f of x. Here's your h. Y. Let me get my purple marker, purple crayon. Back out. ¿Dónde está aquí? X plus h is what needed to get plugged into my f of x spot. Right? So instead of x being squared minus 1, it's quantity squared minus 1. What quantity? That quantity. Sure, why not? X plus h quantity squared minus 1. What got plugged in for the other guy? For the f of x? The x. Why? Because that's who was in there. Why? Well, that's what the input is supposed to do. It goes and it's squared and it's minus 1. If you can't plug into the formula, you can't even start to solve your problem. But if you can plug into your formula, oh, it's a limit problem. Oh, there's x's and h's. Gross. But pause. Look at your limit. Who's supposed to get 0 plugged in for? H, not x. Leave x alone. He just stays. He's just an observer. H gets plugged in for 0. Okay, fine. Let's go plug in 0 for h. So if we go plug in 0 for h, we're going to end up with x plus 0, quantity squared, minus 1, minus x squared minus 1 all over h. Nope. Wait, what was h? The limit's gone because I plugged him in. But what's the struggle? What's the struggle? It's divided by 0 and check it. What's x plus 0? Isn't that just x? So isn't it x squared minus 1 minus x squared minus 1? Keep going, but how? Factor. Ugh. Polynomial division? Ugh. Wait. I told you the steps to this are figure out how to plug in. Figure out how to plug into the formula. Simplify, simplify, simplify what? We didn't simplify anything. What could we simplify? Can't we distribute some negatives and can't we do some foiling action and can't we combine some like terms? And why are we doing all that? Because didn't we just say keep going? Well, how will we keep going? I don't know, but if we can simplify, let's try it. Cool. Kiddos, do some foiling for me. Ready, set, go. What's x plus h times x plus h? I have it ready. Ooh, look how fast that was. 2xh or 2hx, either way, right? Double check, don't kill a seal. Did you distribute your negative properly when this had to go to both terms? Negative x squared plus 1. So I foiled x plus h times x plus h is x squared plus 1xh plus 1hx. They're like terms, so 2hx or 2xh, same thing. Plus h squared minus 1 minus x squared plus 1. Oh, didn't help. If you plug in 0, well, why would we plug in if we haven't reduced any of the wholes? Remember, 0 over 0, we want to reduce something. We can't yet, but what can we do? We can cancel out some stuff. Ah! Go, team. What do you notice about all the terms that are left on top? They all have an h, which I can factor out. And why is it so cool that I can factor him out? I can. Ha-ha! Get rid of my 0 over 0. There's that little shared common factor that I was trying to find. But wait, we've been continually writing limit because we have not been able to solve yet. But what can we do right now? Plug in 0 for only h. And what is left? You have found your first derivative. What? You have found your first derivative. You don't fully know exactly what that means, but you have done it. But for your purposes, you have found how to use the difference quotient to solve this special limit that we have not fully applied yet. But that I mentioned happens to look a lot like that special answer to the huge tangent line problem that is one of the foundational questions to all of calculus and where it came from. So, real quick, before the question, at the very top, simplify the function notation. Simplify the function notation, aka you can think plug in. Use algebraic techniques for solving. So the easy way of thinking about it is, for the difference quotient, figure out how to plug into the formula. Uh-oh. Does that mean you need to know the formula? Should we maybe put like a yellow box around it? Think this guy's important? And the answer is yes. He's also one of our first forever cards in calculus, but coming back. One of the first, not the first. But first step, figure out how to plug into the difference quotient, and then simplify. And what's the goal of simplifying? To keep going. And as you keep going and as you simplify, hopefully you'll get that 0 over 0 reduced. You plug in 0 for h and you're done. Carl, go ahead. Oh, perfect. But then you see 0 goes into h. So if you want, you can go ahead and do an in-between step. That's totally fine for your brain to be able to remember this later. I don't know about you guys. Sometimes things make sense in my brain. And I'm like, sweet, I got it. And 5 seconds later, I'm like, huh? I don't, what just happened? It's like me with church sermons every week. I'm like, oh, it's so good. I'll never forget it. And then I'm like, on Wednesday, no clue what the really good thing was. That touched my heart. So that's why I take notes. And to stay awake. Okay, so coming back. 2x is the answer to this crazy beginning limit problem. So this is what's going to be weird on these. Not only that you have to start with a formula, not only that plugging in gets a little weird because some of you are still kind of bad at function notation. It's okay. It's a weakness. We got to work on it. But also at the very end, x does not disappear. Who disappears? H. But does it work in the beginning? For the difference quotient? Check it. When you go to plug in, to any difference quotient, you will always start off with who over who. Because whatever difference quotient you do, it always has this relationship, so you will always end up with f of x minus f of x all over 0. So with the difference quotient, you can, all the phrases I said yesterday that basically meant take it to the bank, that you're going to have to keep going. And the way to keep going is to simplify. And once you simplify, hopefully you can factor out an h if you've done it correctly. And then you can reduce away and plug in and be done. Okay. So let's go ahead and check the evens on section 12.2. I'm not sure that we're going to go over numbers 47 through 50 until tomorrow because I want to give you a chance to try it now that you've seen it. Does that make sense? But let's go ahead and go over the evens. Maybe we'll look at 48 and 50 and let you guys try 47, 49 tonight. But here we go. Evens, homework spiral, color pens at the ready. Number 1, ooh, they use dividing out technique. I wouldn't mind factoring or division. The factoring out method, although remember factoring doesn't always work so good, so division needs to somehow be brought in. Indeterminate form, the snazzy name. Did we ever write that? Oh, we might not have written it. Indeterminate form. Don't worry, you'll get it next year if you don't get it this year. If you come back, which I hope you do. Indeterminate form. That's the snazzy name for 0 over 0. Keep going. Number 3, one-sided limit. Coming from only one direction, one approach, one of the colored cars, not both. Number 4, the snazzy difference quotient formula that we just talked about. Okay. Number 6, A was 0, B was 1, C was -2. Let me just full screen this puppy. Ooh, can you guys see it? Maybe not. There we go. There's 6, there's 10, -7. I'm not really sure the graph helps so much, but I guess you could have looked at the graph. Number 1248. Some of you would have been like, I don't know how to factor. That's okay. What could you have done instead of factoring? Polynomial division, but how would you have divided a cubed with a? Oh, wait, that's easy, right? But hold on. Did you do the 0a squared and the 0a and then the 64 when you were trying to do your division? Without that, you would have gotten a little bit messed up. But otherwise, it would have been not too bad at all in order to simplify, as long as you remember to distribute your negative. Just a few of you might have messed up on that negative. It happens all the time. Then we've kept on going. Distribute that negative. Anyway, it would have worked out quite nicely. Oh, hey, look. Ha! Plug it in, done. 48. Number 16. Did you guys multiply by a conjugate? The enthusiasm is so overwhelming. Yay. Should have multiplied by a conjugate. But don't let them fool you. I hate their notation because there should be parentheses all over the place to keep it legal and to keep it okay. On the top, you have to FOIL. You have to do the difference of squares to get that radical out. But on bottom, keep them separate. Keep them factored because I'm hoping to reduce with that guy. Which, if you notice, negative 2 plus x is x minus 2. The numerator reduces with the denominator. And then you plug it in. See how they keep rewriting limit? Until they plug in? Super common mistake of beginners. Hopefully not enders. And number 18. Simplify that complex fraction. No! How'd they make that jump? That's impossible. That's ridiculous. I couldn't. Yes, you could. What could you have multiplied top and bottom by? What's my trick? The common denominators. Not just x minus 8. Why not 8 times x minus 8? If you multiply 8 times x minus 8, why is that so spiffy? Distribute in here. The x minus 8's cancel, and who's left? 8. Distribute in here. The 8's cancel, and what's left? X minus 8. Go team. You can make that jump too with just a little bit of practice. All over 8x, x minus 8. Anyway, at which point you simplify the 8 minus 8 cancels. The x over x reduces. You end up with 1 over 8 times, and then you plug it in. Done. Yeah? Mm-hmm.
Where's the minus 4a come?
What did I do over here that showed where it came from? Were you watching? Oh. Guys, what did I do over here that showed where it came from? Polynomial division. So you can put this guy in with the 0a squared and the 0a and the 64. Put that guy out. And as you divide, you have to distribute. And then as you are doing the distribution, then these different terms come out, then minus 4a and the 16. So it looks magic. Technically, they're using something called SOAP, same opposite always positive, factoring a sum of perfect cubes. There's like a formula for it. But I don't like you guys memorizing more than you need to when that might not be what's in there anyway, and you might have to do polynomial division. I'd rather you have a technique that always works. So polynomial division. Melanie?
For 16,
yes. Because just follow their work. There's some work to be done here, right? They didn't show it being done, but there's some work to be done. 16 minus 18 would be negative 2. The minus needs to go to the negative x. That'd be plus x. Check it. Isn't negative 2 plus x the same thing as x minus 2? So what they did is they said, ha-ha, they reduce. Remember, they jump around a little bit. The grad student, I'll just leave it. The grad student doing these answer keys, they're pretty smart and they can make some jumps pretty fast. Well, they make their professor happy who's advising them for master's and PhD degrees. Sure. Not extra credit. It's called they can stay versus they can leave. Okay. We good to keep going? Are there more evens? I think there are. Woo! There are a lot more evens. Whoa! Trig! Woohoo! Did you guys get this one? It was 0 over 0. T-proof skills. Making that guy 1 over sine, making that guy cosine over sine, doing some simplification, maybe it works out. T-proof skills came to haunt you just a little bit. Number 26 was an interesting one as well. Kiddos, what do I need you to do tonight? 47 through 50. I need you to practice that difference quotient. And if you guys didn't just notice, aren't all the evens actually being saved in your notes? So couldn't you go check out these evens on the video or on the PDF? And then come tomorrow with well-informed questions based on what the answers should be. Sound good? Okay. So practice the difference quotient. Wait, don't totally pack up. We still have 4 minutes. So 12.3, let's at least get notes started just a little bit. Let's get notes started just a little bit. The goal today on the calendar was to start 12.3. Totally fine, because the cool thing is our book didn't even know it, but we already talked about the tangent line problem. We already talked about how a tangent line skims the graph at one point. That was very loud. I apologize. So you're not completely coming at this section being like, what? There's a tangent line problem? That doesn't mean you're able to go home and start on this homework necessarily. Some of you might be interested and might want to, but the rest of you are like, nah, I'm good to finish up 12.2. But this might not be as new to you as it might be to some other pre-calculus class that didn't do an introduction to calculus at the beginning of chapter 12. Oh, guys, I just failed. I erased the homework number. What number was section 12.2? It was 68? Okay. So this one's 69. This homework won't be due until probably Thursday? And here's the dealio. How many of you guys are taking A-push on Friday? Oh, that's right. We don't have a lot of juniors. Okay. It's okay. Now you know. Now you can cheer each other on. Exactly. See? Look at that. Encouragement. Keep breathing. In and out the whole test long. It helps. Well, some people forget it.
She's going over so much stuff right now, and I don't remember any of it.
A-push?
No.
AP Bio?
I don't know, water detention.
Guys, why is the tangent line problem a problem? Why is finding a tangent line? Because you don't have 2 points. You only have one. And to get any equation of a line, we can plug in 1 point for point slope, but we need a slope. And what the problem is, the slope needs 2 points. So if the slope needs 2 points, somehow we have to say, okay, here's one y and here's a little bit removed y, and then let's have them get closer and closer together. Wait, one y and a little bit removed y, and getting them to be closer and closer and closer together, 1y and a little bit removed y, trying to get them closer and closer and closer together. Maybe we already answered the question without even realizing it. So tomorrow, section 12.3, we'll dig in as soon as we see how you guys are doing on what? The difference quotient part specifically, but any other questions that you might have on 12.2. Sound good? All right. Ready, set, happy Tuesday. You have 50 whole seconds. Oh my goodness, spoiled rotten.